Airplane has an airspeed of 640 miles per hour at a bearing of south 75 degrees west. Airplane, plane, right here. We're doing this one. North, south, east, west. Draw your directions. South.
Why do you
What?
always
What? Just because it says airplane before. That's all. So southwest, south 75 degrees west. So that means that the angle goes from south towards the west 75 degrees. That is a 75-degree angle. It will always be touching either the north or south line, whichever letter it says. South 75 west. So we need that angle from standard position. Standard position angle starts at the positive x and goes around. How many degrees do I need to go around to make that angle?
180.
180 plus whatever this little tiny piece is, which is 15. 180 plus 15 is 195. So it goes cosine first, then sine. 75 subtracted from 90. And then we put the magnitude in front. 640 miles per hour. 640. For the wind has a velocity of 47 miles per hour. So 47 is the magnitude. We got to fill in the angle. The wind is blowing from the northeast. Northeast. From the northeast, which means blowing that direction towards the southwest. Now, northeast is like exactly northeast, which implies a 45-degree angle on both sides. So when we talk about that over here, this is also 45 degrees, which means that this angle going all the way around in standard position is 180 plus 45, which is 225. You have to draw the picture to know where it's going and to find the angle. Or at least envision the picture, but probably draw. So the resulting vector, wind plus plane, is going to be the resulting vector. So we're going to add these two vectors together. Our calculator, first of all, needs to be in the correct setting. Would that be degrees or radians for this problem?
Degrees.
Degrees, because there's degrees in the question.
Wait, you add wind plus
Wind plus plane. So on our calculator, we got to be in degrees. So shift, setup, angle is set for degrees. I'm good to go. Make sure you are too. And we're going to type these things in. It is 47 cosine 225. Plus the plane, 640 cosine 195. That is the x component of our added up vector. I want to save that so I can refer back to it without typing it. So I'm going to do the store button, alpha A. Negative 651.4. I'm also going to write it down if I need to. 651.4.
So wait, we're just adding them? We're multiplying them out and then adding them?
Yep.
Will you ever come out of us for like how many decimal places?
No, because it doesn't tell you, and you're going to use the stored value on the calculator anyway. So, all right. Now we need the B component, which is the exact same thing, but we're taking the sine pieces. So it's 47 sine 225 plus 640 sine 195. And we're going to save that alpha B, store it as alpha B. Negative 198.9. So that's where the plane actually goes. After the wind blows it just that little bit, that's where it's actually going. Now to find the new speed, speed is magnitude. So to find the magnitude of this, it's the square root of a squared plus b squared. We save those things as A and B so that I can type it in exactly like that in my calculator. That's why I stored them at A and B. If you didn't do the store button, you have to type out those numbers. Square root. A squared plus B squared. If your calculator does not make the big square root around it, you need parentheses around it. .1 is the speed. Miles per hour. The plane itself was only going 640, so the wind is speeding it up quite a bit. Because it's blowing 47 miles per hour itself.
Oh, I was thinking about that. Just, I was like, well, I wouldn't think to scroll by 4 seconds per hour.
Yeah, a little bit of a different angle. All right, to find the bearing, we're going to start with the angle. The angle is arctan B over A. Again, that's why we have these things stored, so we don't need to keep typing them. In the calculator, arctan B over A. If your calculator does not make fractions look like fractions, you need parentheses around your fraction. 16.977, let's just say 17 degrees. Now we need to use that 17 degrees with a picture to put it back into north, south, east, west bearings. So when your calculator says 17 degrees, that's talking about the standard position angle of 17 degrees, right here. That is nowhere near where the plane is actually traveling, because the plane is traveling based off of this component vector, negative, negative, so it's going quadrant 3. Quadrant 3 is straight line across right there. So you can add 180 to get your standard form, but really what we need is the fact that this 17 degrees, vertical angles back from geometry, would also fit right there. If that's 17 degrees, then the angle down here in the other wider chunk of southwest is 90 minus 17, 73 degrees.
And so it would be south 70 west.
So we got south and west are the directions. The number that you use is the one that touches the north-south line, so the 73 degrees. It is south 73 degrees west.